All right, guys, so we are taking notes on page 62 today. This is graphing simple rational functions. Okay, so our essential question is, how are the graphs of f of x is equal to a times 1 over x minus h plus k, and f of x equals 1 over 1b times x minus h plus k, related to the graph of f of x equals 1 over x. Okay, so you guys will notice we had a, b, h, and k, just like when we were working with other functions. They're going to be the same types of things. They're going to change things in the same types of ways, okay? It's just a different type of graph here. So first thing I want you guys to do is go ahead and highlight here. A rational function is any function with polynomial numerators and or denominators. So there are several examples down here. R of x equals x plus 1 over x minus 1. P of x equals x squared plus 3x minus 4 over x. H of x equals 1 over x plus 2. And then kind of from our essential question, f of x equals 1 over x. Okay, so as long as you have some type of polynomial in either the numerator or denominator or both, that counts as a rational function. Okay. All right, so first thing we're going to do is we're going to look at the parent function, okay? So over here on the graph, okay, I'm going to circle right here. So this is the parent function of just the basic f of x equals 1 over x, okay? So our domain here is negative infinity up to 0, because here's our 0, and 0 up to positive infinity, where x does not equal 0. Okay, so basically we've got this asymptote here. As a reminder, asymptote is a line that you cannot cross. Okay, you can get super, super close to it, but you can never cross it. Okay, so here's what we have. In the parent function, we have a vertical asymptote, so straight up and down, at x equals 0. And then we have a horizontal asymptote at y equals 0. Okay, those are the two kind of lines that these graphs cannot touch. So you guys will notice there are two pieces of graph, okay? These are both for one function. This is not two different functions graphed on the same coordinate plane. This is one function that, because there are two asymptotes, you end up with two separate sections of graph, okay? So then we've got one of these big old kind of sample equations here, okay? So just like in a former page of notes, I don't remember off the top of my head which one it is, where we had like, hey, this is what A does, this is what B does, this is what H does, this is what K does. Kind of similar thing happening in this equation here, okay? So you guys will notice that when we have an H and when we have a K, the H and the K will affect the asymptotes, okay? Down here, another thing I want you guys to highlight is asymptotes are only affected by H and K. So your asymptotes do not care what your A or B values are. It only matters what H and K are. Okay, your vertical asymptote will be H. Your horizontal asymptote will be K. So whatever K is, that's where your horizontal asymptote is, and whatever H is, that's where your vertical asymptote is. Okay, and then the reference points are affected by all four parameters, so A, B, H, and K. So one thing I want you guys to add to your notes right now is that for your reference points, okay, you are going to multiply by A or B, and you are going to move by H or K. Okay, so when I say move, we're translating. We're going up and down, or we're going left or right. Okay. All right, so this will make a little bit more sense as we go through some examples. So let's get into our first example. Okay. So we've got g of x equals 3 times 1 over x minus 1 plus 2. Okay, so some things we need to know here. We've got a, Okay, right? A is always going to be out in front. Okay, so our number out in front is 3. So A is 3. Right now, you guys will notice there is nothing in front of X, okay, which means there isn't really a B. But if something's not there, it's a 1. Okay, so our B is a 1 because a 1 won't change anything. Okay, and then if we look, we have X minus 1 here, and we know it's always minus H. So if it's minus 1, that means that H has to be 1. Okay, and then last of all, we've got plus 2, and we know it's always plus K, so that means that our K is 2. Okay, now that we have all of our variables identified, what we're going to do is we're going to use those to fill out our chart for our new graph. Okay, so in this middle column here, what we have is everything for the parent function. So everything that was up in this original table, everything that was on this original graph. Okay, so what we're going to do here is we know that H is equal to 1. So for our vertical asymptote, we're going to have X equals 1. And then we know that for our horizontal asymptote, K equals 2. So our horizontal asymptote is going to be Y equals 2. Okay, again, H, whatever H is, that's your vertical asymptote. Whatever K is, that is your horizontal asymptote. Pretty quick and easy for the asymptotes. Okay, next one, what we're going to do is for our first reference point, okay, it's always going to be the -1, -1. Sorry, that doesn't look like a very good negative sign. -1, and then also +1, +1. Okay, those are our 2 reference points. So what we're going to do is we are going to say -B plus H and -A plus K. So essentially what we're going to do, because this is -1, the reason it's -B plus H and -A plus K is we are essentially doing -1 times whatever B is, right? So our B, we said, was 1, okay? So if we do 1 times -1, right, because our original is -1, and then we're going to add 1 because K is 1. And then we're going to have, let's see, A was 3, so we're going to do 3 times -1 plus 2. Okay, that is going to give us a new reference point that is 0, -1. Okay, all I did to get 0 and -1 was just solve those different little expressions there. Okay, and then for the next one, we're going to have 1 times 1 plus 1. And we're going to have 3 times 1 plus 2. Okay, and that is going to give us the 0.25. Okay, if you need to, go ahead and pause the video to write those down, and then we're going to move over to the back of the page so we can actually get our graph done now. Okay, so on the back, what we've got here is we've got the parent function is already there. Okay, so what's on there is the parent function. What we're going to do first is we are going to put our asymptotes on there, and I'm just going to go ahead and put them in red. Doesn't really matter what color you do them. Our vertical asymptote was X equals 1. So I'm going to come and I'm just going to put a dashed line through X is 1. And then our horizontal asymptote was Y equals 2. So I'm going to put a dashed line through Y equals 2. So this was Y equals 2. And this was X equals 1. Okay, all I did was move my asymptotes. Okay, so instead of the x-axis and y-axis, now we have these new asymptotes based on H and K. So then I'm going to plot my reference points. Okay, my reference points were 0, -1, which is going to be here, and 2, 5, which is going to be here. Okay, the next part sometimes can be a little bit not 100% accurate, because really all you're going to do is you're going to draw a line that goes through the reference point and gets super close to the asymptotes, but never really crosses them or touches them. Okay? Your lines don't have to be perfect, and that one's not very good. Okay? In most cases, they're not going to look super perfect. You just got to make sure they kind of close as you can get. Okay, so there's our new graph. And then we're going to state the domain and range using all three types of notation. Okay, so for inequality, what we're going to do is we're going to say x is less than whatever our asymptote is for x. So x is less than 1, or x is greater than our asymptote. So x is greater than 1. Okay, so for set notation, you're going to use these little curvy brackets, and we're going to say the x is not equal to whatever the asymptote is. So x is not equal to 1. Okay, and then for interval, you are going to say negative infinity, and then whatever the asymptote is, so 1, and then a union of whatever the asymptote is, up to positive infinity. Okay, and then you're going to do the same thing for the range. The only difference is instead of using the vertical asymptote for your numbers, you're going to use the horizontal asymptote. So we're going to say y is less than 2, or y is greater than 2. For set notation, again, we got the curvy brackets. We have y, and y cannot be equal to 2. And then for interval, we're going to have negative infinity up to our horizontal asymptote of 2. It's a union, and our asymptote up to positive infinity. Okay, so the numbers that you guys are using for your domain and range are based on your asymptotes. Okay, all right, take a second to copy that down if you need to, pause if you need to. We're going to move on to the next section. All right, so rewriting simple rational functions in order to graph them. So what we've got here is we've got some division that we have to do, because we have 4x minus 7 over negative 2x plus 4. There's not a really nice way to graph that as is. So what we're going to do is we're going to actually do some long division to be able to write it so that it looks more like one of our example forms here. So either this first one or this second one. Okay, if it can look like that, it's going to be a lot easier for us to graph it. So we're not going to go over the actual long division side. You guys have other sets of notes that go over how to do long division. You can use synthetic, whatever you want to do the actual division. Okay, what's important here is we are going to look at what we get for our quotient and what we get for our remainder. Okay, so what we're going to do here is so instead of dividend, that's usually going to be like g of x or whatever your name is going to be. Okay, so g of x is equal to our remainder right here. This is our remainder. Okay, so that was 1 on top. Our divisor, we divided by, right, I'm just going to call that d, our divisor, was negative 2x plus 4. And then our quotient, so right here, this is our quotient. Okay, so we're going to say minus 2. Now, the bottom there, so the divisor, it doesn't really fit with either the x minus h or the 1 over b times x minus h. So what we can do is we can take a negative 2 out of both of those. So what we're going to have is this is going to simplify down to g of x equals 1 over negative 2 times x minus 2. Okay, so what that tells us, okay, we've got our a right now. There is no a, so that's just 1. our b is going to be -1/2, okay? Because the only way we could have 1 over b be -2 is if we had 1 over -1/2 like that. That would equal the -2. Okay, so, and then our h is 2 and our k is -2. So that means we're going to know that our asymptotes here, we're going to have x equals 2. So we're going to come make an asymptote at x equals 2. Okay, because whatever h is, that's our vertical asymptote. And then whatever k is, that's our horizontal asymptote. So we're going to come make our horizontal asymptote at y equals -2. Okay, then for our reference points, I'm going to come down here and just kind of use the extra part of the paper down here to write in our points. So we're going to have, we're going to do -1/2, so our b, times the original -1 plus 2. And then we're going to have, a was just 1 times -1 minus 2. Okay. And that is going to give us our first reference point of 2.5 and -3. Okay, so 2.5 would be here and -3 would be here. So here's our first point. 2.5, -3. And then we are going to do -1/2 times +1 plus 2. And 1 times +1 minus 2. And that is going to give us 1.5 and -1. So then we would go to 1.5, -1 would be here. Okay, so now that we have our asymptotes and we have our reference points, again, we're just going to draw a line. Wow, that got really wobbly. Okay, again, does not have to be perfect. I say after I fixed it to be more perfect. But you're just going to draw a line. As long as it goes through the reference point and doesn't actually touch the asymptotes, then it's good to go. Okay? Again, for our domain and range, we're going to say x is less than whatever our k was, so less than 2. Sorry, not k, h. Or x is greater than that asymptote, so 2. Y is less than -2, or y is greater than -2. Okay, again, we're just saying domain and range based on whatever the asymptotes are. So x cannot equal whatever the asymptote is. Similarly, y cannot equal whatever the asymptote is. Okay, and then for interval, we've got -infinity up to the interval, or sorry, the asymptote with a union of the asymptote up to +infinity. Okay, same thing for range. We've got -infinity up to the asymptote, and the asymptote up to +infinity. Okay. All right. Pause the video if you need to write that down. And then we're going to move on to the last page. I know this is a lot of writing, so pause as needed. Okay, last page. When given the graph of a simple rational function, you can write its equation using one of the general forms. Okay, so before, I've given you guys equations and you've had to make the graphs. Here, we're going the other way. We are going to be given the graph, and you guys need to make the equation. Okay, always, 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 easiest thing to do is figure out your h and your k based on your asymptotes. So here we have an asymptote that is x is equal to 3. That's our h. Okay, here we have a horizontal asymptote that is y is equal to 4. That's our k. Okay, so already what we know is g of x is equal to a times 1 over x minus 3, because we're going to subtract h, and plus 4 because our k was 4. Now what we need to do is we need to figure out our a. So what we're going to do is we're going to take either of the reference points. I'm going to pick this one just because it's closer, and I'm going to plug them in. So my y is going to go where the g of x is. So 6 is equal to a times 1 over, my x value is 4 minus 3 plus 4. Okay, we're going to end up with 6 equals a times 1, because 1 over 4 minus 3 ends up just being 1, plus 4. So that's really 6 is equal to a plus 4. If I subtract 4 from both sides, I end up with 2 is equal to a. So then now that I know that, I can write my answer, which is g of x is equal to 2 in place of the a, 1 over x minus 3 plus 4. And there's my answer. Okay, pause if you need to. We're going to move on to writing with the format that has a B rather than an A. Okay, again, we're going to do the exact same thing. We're going to find the asymptotes first. This is x is equal to -3, so that's our h. Here we've got y is equal to -1, so that's our k. So we're going to start with g of x equals 1 over b times x minus h, so minus -3 would be plus 3, and then minus 1 on the outside. Okay, we're going to take the reference point. I'm going to take this -5, 0, because a 0 is going to be super easy to work with. So I'm going to say 0 is equal to 1 times 1 over b plus -5, or times -5 plus 3, all minus 1. Okay, that's going to be 0 equals 1 over b times -2 minus 1. Okay, I'm going to add 1 to both sides. You get 1 is equal to 1 over b times -2. Okay, I'm going to add some other colors really quick just to kind of make sure stuff doesn't get lost. But I'm going to multiply both sides by 1b times -2. 1 over b times -2. And what that's going to do is that's going to get rid of the fraction. Okay? So what we're going to do here is we are going to end up with 1 over b, so this is all going to go up here, times -2 is equal to 1. Okay, and then I'm going to divide both sides by -2 to get rid of the -2 that is multiplying. Okay, and I end up with 1 over b is equal to 1 over -2, which means that b has to be -2. Okay, so then when I write my answer, I'm going to have g of x is equal to 1 over -2, because b was -2, and it's 1 over b, times x plus 3 minus 1. Okay, pause the video if you need to copy that down. And we're going to move on to the last thing. I know it has been a long set of notes. Okay, we've got a word problem. Okay, we've been talking about ridges. First thing we got to do is read the problem, so here we go. Mary and some of her friends are thinking about renting a car while staying at a beach resort for a vacation. The cost per person for staying at the beach resort is $300, and the cost for the car rental is $220. If the friends agree to share the cost of the car rental, what is the minimum number of people who must go on the trip so that the total cost for each person is no more than $350? Okay, next thing is identify the question. Our question is, what is the minimum number of people who must go on the trip so that the cost for each person is no more than $350? Okay, next thing that I'm going to do is I'm going to define my variables. Luckily, the diagram is already there. The graph is already done for us. Normally, you guys would have to graph it, but I figured it'd be nice to just have the graph for you. Okay, so we're going to say that C of P is equal to cost per person. And then P is number of people. Okay, so our variables have been identified. We have a diagram over there to use. Next thing is we are going to find some important information. So we know that already the cost per person is $300. Okay, that is already what's going on. Okay, so that actually is going to be our horizontal asymptote because it can't possibly go less than that. Even if 100 people went, you still have to pay $300 per person. Okay, and then we know that the car rental is $220. Okay, really that's all the information that we have. So that's kind of all we need to gather. What we're going to do now is we're going to write an equation. Express it as an equation. So the cost per person, or C of P, is equal to the cost of the rental car divided by the number of people that go plus $300 per person. Okay, if we were going to look at this in terms of how it would change the regular graph, this is going to be a vertical translation. I don't know if you guys can hear the rain. It is like super rainy and windy outside. So this is going to be up by 300. So again, that's why we have this vertical asymptote here in green at 300, okay? Because our K moved it from 0 up to 300. So that is also our vertical asymptote. Okay? And then the 220 over here, what that does is it's a vertical stretch by a factor of 220. Okay, which without seeing the actual, like the parent graph on here, you can't really tell that it's been stretched out, but it has. Okay, so if we then were to look at this graph, okay, so here's where it crosses, this red dot right here. Okay, our graph of our expression is in blue, and then we added this, it's not really an asymptote, but we added this right here. This was the 350 limit. Right? We can't go above that. Okay? So we're going to see where they cross. And in this case, the graph crosses between 4 and 5 people. So that mathematically we could have 4.5, but in terms of actual real world stuff, can you have half of a person go on a trip? No, they either went on the trip or didn't. So we can't take 4 because that wouldn't be enough, right? It would have to be 4.5, but we can't have half of a person, so we have to round up to 5. So the minimum number of people is 5 if they want the cost to be less than $350. Okay, there we go. I know that was a super long set of notes. Thank you for sticking with it. If you guys have any questions, you can email me or talk to me in class.